So in previous videos we had started a module called joint probability distribution, and we had chosen an example how to solve it, what these basic conditions are called as, how to solve it using your standard formulas. And now in this video we shall continue it. Okay, so in previous video we had solved these three conditions, that is first one e of x and e of y, which can be also called as mu of x and mu of y, that is nothing but your expectation of x and expectation of y. Similarly, we in the second condition e of xy is nothing but your expectation of x and y, and third condition, that is sigma x and sigma y are nothing but your standard deviation of x and standard deviation of y. Now still two conditions are remaining now, so we shall solve in this video. Okay, so what does this COV of x and y implies? It is nothing but covariance of x comma y. Okay, so nothing but we shall go to our formula list, that is standard formula list. So what the actual formula says is, okay, covariance of x and y can be found by using this formula, okay, which is nothing but e of xy minus mu x into mu y. Okay, we know what is e of xy. We know that it is expectation of e of x and y. Okay, minus mu of x is nothing but e of x, that means expectation of x, into mu of y, mu y is nothing but e of y, which is nothing but expectation of y. So all these values we have already calculated in our previous condition. See, e of xy we have already solved it, and mu x and mu y is nothing but your e of x, e of y, we have already solved it. E of x, e of y, we need to just take those values and just substitute in this formula in order to find the covariance of x comma y. Okay, we shall do it. First we'll write our basic formula. What it is? Covariance COV of x comma y is nothing but e of xy minus mu x into mu y. Okay. Okay, now in earlier, I mean to say the previous videos we had solved, and those values are already present with us. Okay, we have those values. Okay, nothing but, so where it is, okay, so mu of x, so that means e of x or mu of x, both are one only, so that is equal to 3. We had got the value 3 for mu of x, and that is e of y is nothing but mu y, that is 1. Okay, we shall substitute in this. So mu of x is nothing but your 3, mu of y is nothing but 1. Okay, here minus e of xy also we have calculated in our previous video, that is nothing but e of xy is equal to 3 by 2. So we shall put it 3 by 2. Okay, we can directly solve and calculate, or it is very basic. 3 by 2 minus 3 is nothing but 2 3s are 6, that means we have to cross multiply it. 6 divided by 2 will be your common LCM. Okay, 3 minus 6 is nothing but minus 3 by 2. 2 ones are sorry, minus 3 by 2 will be your answer, I feel. So yes, covariance of x comma y, where it is, okay, covariance of x comma y is equal to nothing but your minus 3 by 2. Okay, okay, now this was my fourth condition. Now last condition of this example is rho of x comma y. Okay, so what do you mean by rho of x comma y? Nothing but it is called as correlation of x comma y. Okay, so let us go back to our formula list, standard formula list. In this we have where it is correlation of x and y is nothing but how we can find, that is equal to covariance of x comma y. What the value we have got for covariance of x comma y, it is taken as numerator divided by sigma x, that is standard deviation of x, into sigma y, that is standard deviation of y. Okay, so this as numerator, this denominator we have to consider. Okay, we shall do it. First we have to write our formula, x comma y divided by sigma x into sigma y. Okay, so we shall just substitute it. And also here covariance of x and y we have found here, we have find. Okay, sigma x and sigma y, do we have find? I feel so. Yes, we have already find. So nothing but, so sigma x we have got 2, sigma y we have got 4.33. So we shall do it. Minus 3 by 2 is your covariance, and sigma x is nothing but 2 and sigma y is into 4.33. So we shall solve it in calculator. Okay, so what will be our value? Minus 3 by 2 divided by 2 into 4.33. Okay, na? So your value will be the, I mean to say, the correlation, that is rho of x comma y is equal to minus 0.1732. Okay, we shall verify it. Minus 0.1732 is nothing. Yes, your answer is correct. Okay, so now here we have completed the first example of joint probability distribution, and under this round we have discussed all these formula list. Yes, all these formulas we have learned how to apply it and how to solve it. I hope it's very clear to you. So in the next video we shall discuss some more types of problems, and in every case they will not give this box. They might give, in some other cases they might give these two boxes and ask us to find this box. I mean to say, they might give the distribution of x table, distribution of y table, and ask us to find the distribution of x and y both. And in that case, how we can find, we shall discuss in our next video. Okay, so till then you can check out my videos. Okay, and if you have any queries you can comment down. Okay, thank you.